Hey guys, welcome to another video. This one is paper 1-2 of May-June 2014 for ATMath. So with that being said, let's move on to question number 1. So we have to show that this fraction can be written as p sec a, where p is an integer value. Now, first thing first, what is integer values? It is whole numbers. Now, whole numbers can be negative or positive. For example, I can say -1, -2, or I can say 1, 2, keep going on and on. So for those numbers, they are called integers. It just needs to be a whole value. Now we have to show these two fractions add up to p sec a. Now, I know at first it can seem to be difficult, but as always, we have to proceed one by one. Now, the first thing we realize is this is addition of the two fractions and the base are different. So what do? We have to make the base become the same. So as we have seen many times before, we have to multiply them by each other. You will have 1 plus sine A multiplied by cos A. Next step is to cross multiply. You will have cos square A plus 1 plus sine A squared. Now, what else do we have? We have to simplify one by one. So you'll have cos square A plus 1 plus 2 sine A plus sine square A. Now divide by the same base, so let's leave it the way it is for now. Okay. Now, for the numerator, what do we notice? We can see that we have cos square A and sine square A. So we can combine those two by rewriting those as 1. Because you know that sine square A plus cos square A has to be 1. Okay, so 1 plus 2 sine A over 1 plus sine A cos A. That will be 2 plus 2 sine A over, same thing again, so just leave it the way it is for now, cos A. Now if you realize for the numerator, we have a common factor, so we have 2 and 2, we can take 2 outside. And 1 plus sine A over 1 plus sine A multiplied by cos A. Now you can see that these two are the same, so they can cancel out. Be 2 over cos A, which is 2 sec A. So the value of k here was 2, and your answer is this one. 2 sec A will be your answer. That will be question number 1. Okay, so let's move on to question number 2. So on the Venn diagram below, we have to draw the sets of A and B as indicated. So part 1, we have to show that the intersection of A and B equal to the empty set or to 0, which means that they do not meet. If we have A here, B will not meet with A because the intersection is 0. That's the first one. Now for this one, you can see A is a subset of B, so A has to be inside of B. So this is A and B. That will be your answer for part A. Now for part B, we have a universal set, and sets P and Q are such that the number of elements in total is 20. So everything together is 20. Now, the number of elements of P and U is 15. Number of elements of P is 13. And finally, of P and Q is 4. So we have to first use those values or information to draw a Venn diagram to help us. So let's first do that. This is your Venn diagram. This is the universal set, which shows everything together will be 20. So P is here. We know they meet, so P and Q. This is Q, this is P. Okay? And we know that together they have 4 elements. So here we have 4 elements. Now, number of elements in P is 13, so P is 13. So only P will be 13 minus 4, that should be 9. Now, P union Q is 15, so this and this should give you 15. So this will be 15 minus this 2, that should be 1. Now we know everything together will be 20. So outside here will be how many? 20 minus 14, that should be 6. So question number 1, find the elements, number of elements in Q. As you can see, Q is 4 plus 1 is 5. Part 2, find the number of elements in P union Q prime, which is outside of the set, it is 6. And finally, we have to find P intersecting Q prime. So first, P is here. Q prime will be outside of Q, so it will be this one. So that will be 9 as your answer. That is your question number 2. Now let's move on to question number 3. So here we have to sketch the graph of y for this domain of x between -2 and 3, showing the coordinates of the points where the curve meets the x and y axis. So this is important here to show where it meets your axis. So the way I like to proceed with this question is I like to first ignore the modulus. So I would assume or let y at first be 2x plus 1 times x minus 2. Then I will find where it meets my axis. For example, you would say at x-axis, what do you know? You know that y has to be 0. Replace, you'll have 0. Then find the values of x. So x will be minus half, x will be 2. As you can see, we have 2 points, which is minus half, 0, and then 2, 0. Now let's continue on that. At the y-axis, what do we know? X has to be 0. Replace back in your equation, so y has to be, so 0 here will be 2 times 0 is 1, so 1, so 0 is 0 plus 1 is 1, and multiply by the value of minus 2. That should be minus 2. So the point is 0, minus 2. That is on the y-axis. Now let's continue. Because we can see or we know that this one is a quadratic equation, so you will have to have a maximum or a minimum point. So one way of doing this, so there's many ways of course of doing this. I like to expand the brackets. You will have 2x squared minus 4x plus x minus 2. That will be 2x squared minus 3x minus 2. Okay, so now we have to find the stationary value, which is the minimum point. We know this happens when dy by dx have to be 0. So let's find dy by dx. That will be 4x minus 3 is 0. So from this, x has to be 3 over 4. Now find the corresponding y value. So y will be 2, 3 over 4 square minus 4 times this plus this and then minus 2. So let's find out what do we have for those values. 2, then we have 3 over 4 square minus 4 times 3 over 4 plus 3 over 4 minus 2. That will be minus 3, 1 over 8. So the minimum point will be 3/4 and minus 3, 1 over 8. Okay, so now we know all the points that we need to know. We can first draw the first graph. Okay, let's do that. So of course here you will be using a ruler. Don't do like me. So I will first draw my x-axis. And then I will draw my y-axis. Of course, it is not straight. It should be straight, okay? Now, let me first put all those points that I know. This is, let's say this is minus, let's say it's here. This is 2, let's say it's here. So let's say minus half and 2. And then we have this point, y will be 0 minus 2, let's say it's here, for example. And then this point, let's say it's somewhere over here, if that makes sense. So it should be looking somewhat like this. Right, so let me continue. So this will be joining with this. Okay, so it's not perfect, should be pretty smooth. That's the point of your graph, should be looking smooth. Okay, so that will be approximately the shape that we have for the first draft. Now, we have to, so what is the meaning of modulus? Now we have to understand. So this is the graph of this one, but we are not trying to find this, obviously. We're trying to find the modulus graph. So the idea here is that everything below the x-axis, which is negative, will be reflected on top. So anything here will be reflected on top. That's the idea. Okay, so that will be your answer. So basically, in the end, you will have to erase the one at the bottom, and the one at the top will remain. So this one will go away, and this one will be your answer. So that's one way of doing this question. Okay, so of course you have to, this will be 2, this was minus 2, become 2, and this one becomes, it was 3/4 minus, become the value of plus here. Okay, so now as you can see, the curve is only defined between those domains, those values, this domain, from minus 2 to 3. Let's find the values for that. So when x equal to minus 2, what is the value of y? So that will be 2 times minus 2 plus 1 times minus 2 times minus 2. That will be minus 12, which is 12 because of the modulus. So let's try again because it should be positive for some reason. Let me check. So 2 times minus 2 plus 1. That should be minus 3 multiplied by minus 2 minus 2. That will be 12, exactly. So for the value of minus 2, let's say it's here or here, we can see that the curve will be stopping about this point. That's the corresponding value that we have to draw. Now for the value of 3, let's find out. 3 will be what? 2 times 3 plus 1 times 3 minus 2, that will be 7. So for 3, the value has to be 7. It's 3, and of course this has to be going. We have to extend this part to show this is 12. Okay, so that is the points you can find pretty easily. Replace in your equation and find the corresponding values of y. But the main point here, you have to show this is 2, this is minus half, and this is 2. These are the main things you need to show for your marks. Okay, that is question part 1. Now for part 2, we have to find the non-zero values, okay, of k, for which this equation equal to k has 2 solutions only. So it's only 2 solutions. Now, what is this? If you observe, we have just drawn this graph. This is y. So we're trying to find for what values of k this equation has 2 solutions. Now, what is y equal to a constant? For example, what is y equal to 1? Y equal to 1 is a horizontal line. Now, so it is a horizontal line at the value of y equal to 1. Now we are trying to find for what values of k our horizontal line would only have 2 solutions. Solutions mean 2 points of intersection. For example, if you go back to our graph, let's say my graph is something like this. Okay, so right now my graph looks somewhat like this. It's not perfect, so we just need to understand the idea. So if I draw a horizontal line here, what can you see? You can see there is 1, 2, 3, 4 points of intersection, and this is not what we are looking for, so we have to keep going up. What if I draw my line here? It will be 1, 2, and 3, which is still not good. We have 3 points of intersection, so our line should be above this maximum point. So when you draw this, you have only 2 points of intersection, which means only 2 solutions. So basically y has to be more than this maximum point, which is more than 3/1/8. That is initially, of course, but now you have to also observe your graph. You can see that your graph stops right here. So it means that we can only have the value. So here we know this is 3/1/8. So k only lies between those two values. From observation, you can see that is only possible for k, so that we have two solutions. So basically, the value of k, this is not y, this is k, sorry. K has to be between the value of 3/1/8 and then the value of 7, according to the diagram. So on the marking scheme, you will see this one. They will give you a mark for this one. I guess they did not, they were not strict for this part, but if you understand what we are trying to find, because your domain is only defined for those two values, your graph will look exactly like this. And for the solutions of 2 points of intersection, you can see that it is only possible between those two values. So what if I draw a line here? You can see I have only 1 point. It will not be valid. So only between those two, I can have two solutions. So that will be my answer for this question. That will be part 2 of question number 3. Now let's move on to question number 4. The region enclosed by the curve y equal to 2 sine 3x, the x-axis and the line x equal to a, where a is between 0 and 1 radians, lies entirely above the x-axis. That's a long sentence, God. Given that the area of the region is 1/3, okay, we have to find the value of a. So in those kind of questions, I will first recommend draw something to understand what's happening. For example, I have my y-axis, I have my x-axis. So I know sine curve looks something like this. So you will have to have a shape like this, right? So I will just need to find those two values to see what is that. This is obviously the value of 0, but we can check. So the idea here is we have to first draw the curve. And how do you draw a curve? You have to use a table of values. Wow, the police is really annoying. Anyways, this is first begin with a value of 0. Then we can choose any values that you want. We can try 30 and 60. Let's see what happens. So 0, this will be 0, which will be this point. 30 will be the value of 2. You will see 2 will be the value here. And then 60, that will be 0 again. So which means this is 60 degrees, which is pi by 3, right? And this is 0. So this is the area above the x-axis. So the idea is very simple here. We are trying to draw something to understand what area are we trying to find. Okay. Now what is pi by 3? Pi by 3 is 1.0437. Okay. So we know that a has to be less than 1. So it has to be before this value. So for example, we can choose a to be somewhere about here. So x equal to a, as you can see, it is a vertical line. So which means this value here is a. And the area that we are referring to will be this area, which is a positive area above the x-axis between the value of 0, because you can see it cuts this point, so 0 and until a. So how do you find area of a region below the curve? So we have to use your formula, which is integration of a and 0 of the curve, which is y, to sine 3x dx. So we know this is equal to 1 over 3. It is given to you by the question. So we have to use that to solve for the value of a. So 1 by 1, that will be 2 minus cos 3x divided by 3. That will be between a and 0. That will be 1 over 3. Now let's simplify. You will have what? Minus 2 over 3 cos of 3a minus 2 over 3, and that will be cos of 0 equal to 1 over 3. So simplify, you will have minus 2 over 3 cos of 3a minus 2 over 3. This is 1 over 3. Now we can now simplify to see what happens. Of course, so I think I missed something here. It is minus, so I forgot the minus sign here. Minus, minus. So that will be minus 2 over 3 cos 3a. That will be 1 over 3. This will be plus. So when you send this over here, become minus 2 over 3. This will be minus 1 over 3. Okay, so simplify. Minus 2 over 3 cos 3a is equal to minus 1 over 3. So cos 3a will be, this will cancel out, and this will be 1 over 2. So we have to solve this equation for the values of a. Now, cos of, so 3a will be cos of minus half, which is pi by, so usually, again, you can check if you want to. So cos inverse of 0.5 will be 60 degrees, which is pi by 3. A will be pi by 9. And this will be your value of a as required. Now, of course, we can find the other value. When cos is positive, it will be in your first quadrant and in your fourth quadrant. But of course, for the value here, it will be too big anyways, because a has to be between 0 and 1. So we only take the smaller value, which is this one, for the value of a. That will be your question number 4. Okay, so let's move on to question number 5. Given that 2 power 5x times 4 power y is equal to 1 over 8, show that we have this equation. So this one is pretty easy, I would say, because we have done this many times before. So by observation, you can see that number 2, the base 2, the base 4, the base 8, they are all what? Powers of 2. For example, what is 2? 2 is 2 power 1. What is 4? 4 is 2 power 2. What is 8? 8 is 2 power 3. So let's first replace all those values by the base of 2. This one will be the same because it is 2 already. Then we have multiply. Then we have 4 is 2 power 2 equal to 1 over 2 power 3. Now we have to simplify, so that will become, so when you have multiply for indices, we can add them. So the base is the same, 2, 2, so we write 2. Here we have 5x, 5x. And here we have multiply, so when you have multiply for indices of the same base, we can combine them, become plus this. 1 over this can be written as 2 minus 1 over 3. So as a side note, let's write this down. So if you have 1 over a power 3, it can be written as a power minus 3. For example, as a side note for you to know, we can simplify this. Now, since the base is the same, so this goes away, you will have 5x plus 2y is minus 3. And this is shown as required. Let's move on to part 2. So we have to solve the simultaneous equation. So this, as you can see, was from part 1. So from part 1, we realized this could be written as 5x plus 2y is minus 3. Now how about this one? Let's do some observation again. So we have the number, the base 7, we have the base 49, and here we have 1. So how can we connect them to each other? So again, by observation or by practice, over time you will realize that this is what? This is 7 power 1, this is 7 power 2, and this is anything power 0 is 1. So we can replace those values by these in the equation. So this one will be 7x, because it is the same, right? Multiply, here we have 49 will be 7 power 2 times 2y will be 4y equal to 7 power 0. Now the same steps as before, we have to combine them in a way. So here you will have 7x, multiply becomes plus, here we have 4y, and that will be 7 power 0. Now as you can see, they have the same base, we can cancel out. So you will have x plus 4y, that will be 0. So x will be minus 4y, and that will be my equation number 2. So now I can solve these two simultaneous equations to find the values of x and y. So replace the value of x, in this you will have 5 minus 4y plus 2y has to be minus 3. Step by step, expand the bracket, you will have minus 20y plus 2y, that will be minus 3. So you will have minus 18y has to be minus 3. So y will be minus 3 over minus 18. That should be 1 over 6. But always, let's check. 1 over 6. That is your value of y. Now x will be what? Minus 4 times 1 over 6. That should be minus 2 over 3. So cancel 2, 3. That will be your answer for question number 5. Now let's move on to question number 6. So we have three matrices, x, y, and z, given to you. Now write down all the matrix products which are possible using any two of these matrices. Do not evaluate those products. Now, before you do this question, you have to understand, when is matrix product possible? So to understand this, we first have to go to the basics. So how do you describe a matrix? Usually we try to name a matrix by its dimension. For example, here, matrix X is what? Is a 2 by 2 matrix. So this is the dimension of matrix X, a 2 by 2 matrix, because of 2 rows and 2 columns. Same way, what is matrix Y? What is the dimension of matrix Y? It is, we have 1, 2, 3 rows, so 3 by 2 because we have 2 columns. So Y is a 3 by 2 matrix. And for Z, we have 1 row and 3 columns, so it will be 1 by 3 matrix. Okay, so these are the dimensions of those matrices. Now, something we have to know is, when are matrix product possible? So, for example, we have a matrix n times m, and then we have, let's say we have k here. So it is only possible if this and this here is the same. I hope that makes sense. So let's say we have a matrix which is n times m matrix, and we have another matrix which is m times k. So this is a possible product because of these two are the same. So the same way we can check for the rest. So let's try, we can try. Is x, y possible? Question mark, right? We don't know yet. So let's check. X is a 2 by 2 matrix. Y is a 3 by 2 matrix. As you can see, these two are not equal, so it is not a possible product. So xy is not good. Now we can try. How about yx? Y is 3 by 2, x is 2 by 2. Now if you check, these two are the same, so it is a possible. So your first answer is matrix product xy is possible. Now let's try other values. So by observation, you can see you will try this one. You will try z, y, because z is 1 by 3, y is 3 by 2. So these two are the same, so because of that, zy is possible. You can try other combinations, but you will see that for the other ones, it will not be possible. So your answer will be yx and zy for matrix products. Now let's move on to part B of the question. So we have two matrices A and B given to you. We have A and B, so we have to find the matrix B. So let's use this equation. So here we have A times B gives you 3 minus 6, 9 minus 3. Now we want to find the value of B, so we have to eliminate the value of A. So how can you do that? You have to pre-multiply by its inverse on both sides. So when you multiply this on one side, you have to also multiply this on the other side, so you don't change the equation. So once you do that, you can see that this will cancel out. It becomes the identity matrix, and it will just cancel out anyways. So B will be equal to the product of these two matrices. But now we have a problem, is that we do not know what is A inverse. So we have to first find A inverse. So to find A inverse, we must first find the determinant of A. So let's cross multiply, that will be 5. So 5 times 1 is 5, right minus, and minus 4 times minus 2 will be 8, that will be minus 3. Now we have to find the adjoint matrix of A. Let's see what happens. So we change those two positions, 1 goes up, 5 goes down, and we have to switch the sign of those two. Minus 4 becomes 4, minus 2 becomes 2. Now, A inverse equals to what? You have to know. A inverse is 1 over determinant, which is minus 3 times 1, 4, 2, 5. Now replace this value, or this matrix, back in your main equation. So, we know B has to be minus 1 over 3, 1, 4, 2, 5, multiplied by 3 minus 6, 9 minus 3. So we have to multiply rows by column. So let's do that. So let's first leave the minus 1 over 3 outside. So rows by column, so 1 times this plus this times this. So 1 times 3 plus 2 times minus 6. That will be what? Sorry, mistake. So 1 times 3 plus 2 times minus 6. That should be minus 9. Now for this value, so rows by column, 1 times 9 plus 2 times minus 3. That will be 3. And this one now rows by column. So 4 times 3 plus 5 times minus 6, minus 18. And finally, 4 times 9 plus 5 times minus 3. That should be 21. So simplify. Divide by this value, you will have. So if you're not sure, you can always use a calculator, but it's pretty simple, right? So minus 1 over 3 times this should be 3, minus 1, that should be 6, and that should be minus 7. That will be your matrix B. But again, it is always best to check with a calculator, because sometimes you can make stupid mistakes, and this will guarantee you have the right answer. Anyways, that is question number 6. Now let's move on to question number 7. The diagram shows a circle, center O. Okay, now we have the radius is 8, so which means this is also 8 in value. Now we have points P and Q lie on the circle such that the chord PQ is 12. Okay, now part 1, show that theta is this value correct to 3 decimal place. Okay, so how do you find the value of theta? So according to this information given to you, we can derive something. Let's find out. So you're given this triangle here, right? As you can see, this is the same. That will be 8, 8, this is O, this is Q, this is P, and this is 12. But if you observe, if I were to break this triangle into half, this will be 6, and this will be 6. The reason why it is exactly 6 and 6 is because of these two. If these two are the same, these two will have to break down into half and half, okay? So now this will be 90. It is a perpendicular line. And let's first call this one alpha, okay? So to find theta, as you can see, theta is the big one. It will be 2 times alpha, because this is also alpha, okay? So let's first look at this triangle that we have. We have this one now, right? This will be 6, this is 90, this is 8, and this is alpha. So how do you find the value of alpha? If you observe, you will use SOHCAHTOA, pretty simple. SOHCAHTOA. So we know the hypotenuse, so H. We know this is the opposite side, so O and O. As you can see, this one will be chosen. So we have to use sine of alpha is opposite side over hypotenuse. So alpha will be sine inverse of 6 over 8. So this will be in terms of radians. That will be 0.848. But now you want to find the value of theta. So as you can see, theta is simply 2 times alpha times 2, 1.696. And now correct your 3 decimal place. You can have shown that theta will be 1.696. This is shown as required. Let's move on to part 2. So here we have to find the perimeter of the shaded region. So let's have a look. What side are we looking for? So first thing, what is the perimeter? It is the distance around the region. For example, here we have to find QP, PQ. This is the perimeter of the region. So as you can see, so the perimeter is given by chord QP plus arc PQ, for example. So this is given to you already as 12, so let's write this down. But as for the arc, we have to find the value. Now if you observe, if you know theta is 1.696, what is the value of this angle? So you would say 360 degrees, which is 2 pi minus 1.696. That will be 4.587. So now, how do you find length of arc? So you have to use your formula. So let's write this down. Arc length is found by using r theta, which is so let's not call this theta here. Theta is just the angle. Let me call this r beta, because we have used theta here already. We don't want to confuse you, so we just change the name to beta. So radius, as you have seen, it is 8. It's given to you. Now beta, as you can see, it is this angle here, which is 4.587. Okay, so times 8, that should be 36.69 this. Plus 12. That will be 48.7 centimeters, correct to 3 SF, not decimal place, 3 SF. Okay, so the main point here is we have first to know what is the perimeter, which is the distance around the region, which is this and this. So this is given to you, so you have to find this one. Now this one is an arc, and you can find arc by using your formula, which is r times the angle. So first let's find the angle, right? And then we have to apply in the formula. You can find the value and replace and find the perimeter. That is part 2. Now for part 3, we have to find the area of the region. So in this case, let's break it down piece by piece. So area, we can first find the area of this one, QOP, of the big sector. So let's do that. Let's find the area of major sector QOP. As you guys must know by now, the area is found by using your formula, half r square of the angle beta. So usually we call this theta because here we have theta already. I changed the name to beta. Okay, so this one is called beta, for example. Now area will be half, r square will be 8 square, beta will be 4.587. So let's do that. Half times 8 square times 4.587. That will be 146.784. That is this area. So we found this already. Now we want to find this one. Now if you break this down into another piece, you can see. So right now we have this. We have something like this. For example, this is Q, P, and O. So for you to find the area of this, how can you find that? So pretty easy. How do you find area of triangle? So we can first ignore this one because we don't need that part. We have to look just at the triangle. So triangle is what? We know the angle and we know the two side. So since we know the angle and the two side, we can use the formula, which is half times the two sides and sine of the angle in between to find the area of the triangle. So half times 8 times 8 times sine of the angle is 1.696. That will be 31.7495. So finally, the area will be part 1, which is 146.784 plus this one, 31.7495. That will be 178.5335. Now your answer will be correct to 3 SF usually. So that will be 179 centimeter square. That will be your question number 7. Now let's move on to question number 8. How many different 5-digit numbers can be formed using the numbers 1, 2, 4, 5, 7, 9 if no digit is repeated? So pretty easy. So let's say we have 5 spaces because we want to form a 5-digit number. Now from this list I have 1, 2, 4, 5, 7, 9. I have 6 numbers. So for the first number I can choose any of those numbers, so I have 6 choices. Let's say I choose 1. Then for this one I have 5 choices. Let's say I choose this one. Then I have 4 choices. Let's say I choose this one, 3 choices and 2 choices. So 6 times 5 times 4 times 3 times 2. That will be 720. Now if you guys want to use formula directly, that is okay as well. We have 6. We have to permutate 5. So 6. That will be 720 as well. So same answer for part 1. Now for part 2, how many of these numbers are even? Now, how do you know a number is even? So the number has to end with an even value, right? So again, let's write down these numbers. We have 1, 2, 4, 5, 7, 9. So we have to form a 5-digit number. Now let's see, we have one even number here. We have 2 even numbers. So for a number to be even, we have to understand this. It has to end with an even value. For example, if I look at this number, 1, 3, you would say this is not even because it ends with an odd number, right? Now let's say if I write 1, 2, you say this is even because it ends with an even number. If I write 1, 4, it is even because it ends with an even number. So the same logic applies here. For this number to be even, it has to end with an even number. So here we have only 2 even numbers, so we have only 2 choice to end our number. So let's say I choose 2, right? Now for everything else, we can put any numbers, it doesn't really matter because this is the main condition for it to be even. Now I have 1, 2, 3, 4, 5, so 5 choices remaining. I choose this one. Now I have 4 choices. This one, I have 3 choices. This one, I have 2 choices. So multiply them by each other. So 5 times 4 times 3 times 2 times 2. That will be 240. Right, for part 2. Now for part 3, we have 2 conditions. The numbers need to be less than 60,000 and has to be even. So whenever you have 2 conditions, you have to look at case by case. Okay, so again we have numbers 1, 2, 4, 5, 7, 9. Now for numbers to be even, it has to end with 2 or 4. That makes sense. Now for a number to be less than 60,000, it has to begin with a number which is less than 6. So it can begin with 5, with 4, with 2, or 1. Okay, so let's look at each case by case. So let's say, assume case number 1. Let's number begin with number 1. So we have 5 spaces, 1, 2, 3, 4, 5. So we put 1 here, and we forget about 1. So because we assume it is beginning with 1 already, we put the number 1 here and we forget about it. Now for the number to be even, we have 2 choices. So we have 2 choices right here. Let's say we choose number 2, gone, gone. So let me write this down again. That will be 1, 2, 4, 5, 7, 9. That is for this one. Okay, so basically I put 1 here, I forget about 1. Because this is what we are assuming for our case number 1. Now, for the number to be even, I can choose either 2 or 4, so I have 2 choices. Let's say I choose 2, go away. Now I have 4 numbers remaining, so for those 3 places, I can put any of those numbers. So let's put a number here. So for this number, I have how many choices? 1, 2, 3, 4. We have 4 choices. So let's say I choose 4, whatever. Now for this number here, we have 3 choices. As you can see, 1, 2, 3. Let's say I choose this number. And for this number here, I have 2 choices. That will be here. So the conclusion is, if I begin with 1, which is an odd number, I will have this many ways, which is 4 times 3 times 2 times 2. That will be 48. Okay, so basically, if I begin with 1, which is an odd number, I will have 48 choices or numbers. Now let's go look at case number 2. If I begin with number 2, so same things, so 1, 2, 3, 4, 5. Numbers will be 1, 2, 4, 5, 7, 9. Now, if you begin with number 2, let's assume we put 2 here and we forget about 2. That's the assumption. Now, for the rest, let's see. For the number to be even, we have to end the number with an even number, so we have only 1 even number remaining, so we have only 1 choice. So let's 4 is out. Now for those numbers, we can put anything, right? You can choose between those numbers. So we have 1, 2, 3, 4. We have 4 options. Let's say we choose 1. Then we have 3 options. Let's say we choose 5. Then we have 2 options. So that will be 4 times 3 times 2 times 1. That will be 24. So conclusion will be, if I begin a number with an even number, you will have 24 numbers that is satisfy this condition. So now for the rest, as you can see, we have 2 other cases. we can, number 3, begin with 4, and number 4, begin with 5. Now, question for you if you have been following or not, can you begin with 6? So, begin with 7. Can you begin with 7? The answer is no, because your number has to be less than 60,000. So, you only have 2 more cases to go. But as you have realized, from what we said, if you're beginning with an even number, you will have 24. So if you begin with 4, which is an even number, you will have 24. So same way of thinking. If you begin with 1, which is an odd number, it is 48. If you begin with 5, it is an odd number, so you will have also 48. So your answer will be, if you have to add this, this, and this. Okay, so 48 plus 48, 24 plus 24, that should be 144 as your answer. So 144 numbers can be formed from those conditions. Now for part B, how many different groups of 6 children can be chosen from a class of 18 children if the class contains one set of twins who must not be separated? So this is the main condition. So we have a class of 18, right? That's something that is given to you. Now on this class of 18 we have 2 here, which is a twin, and the rest is 16 people. Okay, and we want to form a group of six children. So we have to look at each case. So the first case is we do not include the twins. That's my first case. So we just don't include the twins. So let's see. So from the 2 twins, we don't choose anyone. From the 16 people left, we have to choose 6. Okay, so 2 choose 0 times 16 choose 6. That will be 8008. Now let's look at the number 2 options. Number 2, we have the twins. So that will be the other way of choosing. So now if you have the twins, you will have to choose both because they say they cannot be separated. So from the 2 twins, you have to choose both. And from the remaining 16, you have to choose 4 people because you have to have 6 people in total. So 2 plus 4 is 6. So let's find out. 2 choose 2 times 16 choose 4. That will be 1820. So 8008 plus 1820, that will be 9828. And this will be your answer for part B of question number 8. Now let's move on to question number 9. So here we have a solid cylinder, has a base radius r and a volume of 4000. So whenever you have question which is about volume, shapes, area, so you can always draw something. So for example, what is a solid cylinder? It will be something in this shape, right? Solid means it is closed on the top as well as the bottom. This is what it means to be a solid cylinder. Now, the base radius is r, okay, and the volume is 4000. That has been given to you. Now, part 1, we have to show that the area is given by this formula. So, how do you find the area of a solid cylinder? So let's look at the shape. We have to add the top and bottom and also the curved surface area. So surface area is top plus bottom plus curved surface area. So top is pi r square, which is a circle. Bottom is also a circle. And plus the curved surface area is 2 pi r h. So this is the formulas you have to know by memorization, I would say, because I don't think this is given to you. So by practice, you will know this by heart. So no worries. As long as you keep doing those questions, you will know this by heart. So simplify, that will be what? Pi, all square is all square, that will be 2, right? Then we have plus 2 pi r h. But now, this is the area, but we have to express this in this form. So we have to use something they have given us, which is the volume. So how do you find volume of a cylinder? So volume is equal to pi r square h. Volume is 4000, which is pi r square h. As you can see, in this formula here we don't have h, so it means that I have to remove h from this formula. So let's make h become the subject. You will have 4000 over pi r square. So replace this one back in your main equation. So a will be 2 pi r square plus 2 pi r times 4000 over pi r square. Cancel, cancel. So a will be 2 pi r square plus 8000 over value of r. And this is shown as required. It's the same as this one. That will be your answer for part 1. Now for part 2, given that r can vary, okay, find the minimum total surface area of the cylinder. Now, when you have to find a minimum value, you have to look at the, so as you guys know already, at the minimum value, what do we know? We have to find dA by dr has to equal to 0. The derivative has to equal to 0 at the max or the minimum value. So since we know that a is equal to this, we can find this. So now let's rewrite a. A can be written as 2 pi r square plus 8000. Now let's bring the r up. You will have r power minus 1. Now to find dA by dr, that will be 4 pi r minus 8000 r power this. Let's rewrite this. You will have 4 pi r minus 8000 over r square is 0. Now we have to simplify this. We have to remove this value here. So multiply by r square everywhere. You will have 4 pi r cubed minus 8000 equal to 0. So pi r cubed will be 8000 divided by 4, which is 2000. And then r cubed will be 2000 divided by this value. So finally, you conclude that r has to be root of this value. Okay, that is the first part. Now, we want to find the minimum total surface area. So basically, we want to find a at the value of r equal to this value. So let's evaluate this value to see what is that. So 2000 divided by pi, we have to find the cubic root of that. That should be 8.603. So we have to replace this value back in our main equation, which is a equal to 2 pi r square plus this over r. So very easy, 2 pi answer square plus 8000 divided by answer. That should be 1394.9. So the area, let's write this down correct to 3SF. That should be 1395. Sorry, this is not 3SF, this is 4SF. So let's correct this. That should be 14. So this is 1394.9. So correct to 3SF, that should be 1390 for the area. Now, what's next? So we have to prove it is a minimum value. So usually you prove this by using the second derivative, which is d2a by dr square. So we have to redifferentiate this one. That will be 4 pi minus, so we have to first multiply this by this, that will become plus 16,000 r power minus 3. That will be 4 pi plus this over r cubed. So the point is that you have proven that because the value of r is positive, which means r cubed also have to be positive. Now if this is positive, this value is also positive. This is positive by itself, so it means that at the value of r equal to root this, we have shown that d2a by dx2 by dr2 is equal to more than 0, which is positive value. Since it is positive, it means that the stationary value of a, which is area, is a minimum value. So you have to show this one to show it is a minimum value. So this is the main thing you need to show. Okay, as you can see, I always proceed step by step to question number 10. In this question, I is a unit vector. Due east will be in this direction, and j will be due north. That's the idea. Okay, so at 12 o'clock, a ship leaves port P and travels with a speed of 26 in the direction of this. So direction 512 will be somewhat like this. It should be a straight line. Okay, now we have to show that the velocity of the ship is given by this. How do you find velocity? Pretty easy. Take the speed, multiply by the unit vector in the direction of this one. So let's find out. So what is the unit vector? Let's call it u. So that will be what value? So that will be let's first find the magnitude. That will be 25 plus 144. That will be 13. So the unit vector in that direction will be the vector itself, which is 5i plus 12j divided by 13. So the velocity will be 26 multiplied by 5i plus 12j over 13. That will cancel out, and your value will be 10i plus 24j. Okay, so that will be your answer for part 1. Now for part 2, write down the position vector of the ship relative to P at 4 o'clock. So from 12 o'clock to 4 o'clock, we have 4 hours has passed. So the position vector will be what? Pretty easy. We just have to take the velocity right here times 4, because it was initially at that value. After 4 hours will be times 4, right? That will be basically, the idea is that the new position will be, you will take 4 times the velocity, which is the time taken times this will give you 40i plus 24j. Now for part 3, find the position vector relative to P t hours after 16 hours. So pretty easy. It will be, initial position was at this one, which is 40, 24. That was the initial position. And then t hours after will be what? Plus t times the velocity is given by 10 and 24, as we have seen from part 1. That will be the position vector of the ship. Now this is your answer, or you can write this down as this, which is 4t plus 10 ti plus 24 plus 24 24 plus 24j something. I think I did not multiply this here, so this is a mistake. Let's do that. 24 times 4, that should be 96. That should be 40i plus 96. So this is not the right value. So that will be plus 96j. 96tj. I guess it is late right now. Maybe I'm just tired. That should be. This is 96, right? The initial position is 96. This should be 24. Sorry. So let me write this down again. It should be 40 plus 10 ti plus 96 plus 24 tj. So that will be the position vector t hours after 4 o'clock. Okay. Now we have another thing now. We have a speedboat at 4 o'clock leaves the lighthouse, which has a position at this. So this is the initial position of the lighthouse or of the speedboat relative to P. Now it intercepts the ship. The speedboat had a velocity of this value. So part 4, we have to find the position vector of P t hours after 16 hours. So pretty easy. It will be the initial position, which is 120, 81, plus t hours times the velocity. Okay, so you can leave your answer just like that, or you can write this in this form. It's the same thing. Okay, that will be your answer for part 4. Now for part 5, find the time at which the speedboat intercepts the ship. So we have to find the value of t, or the time, but first we have to find t for which they meet. If they meet, they have the same position. So we have to take part 3 equal to part 4 to find that. So 3, you can see we have 40 plus 10t and 96 plus 24t is equal to part 4 is given by 120 plus minus 22t, 81 plus 30t. Now we have to solve one by one. So first thing, we have this equation, which is 40 plus 10t equals to 120 minus 22t. Now, let's send every t to one side. You will have 32t will be 80. So t will be what? 80 divided by 32. That will be 2.5. So the time taken will be 2.5. Now, what is we are trying to find the time at which they meet. So pretty easy. When the speedboat left the lighthouse, it was 16 o'clock. 2.5 hours will be 2:30. That will be 18:30. So they will meet at this time. So 2.5, 5 is 0.5 hours, which is 30 minutes. Okay, that's why I wrote 2:30. I will need to also find the position vector relative to P. So pretty easy. We place the value of t in one of those. So the position vector will be what? So 40 plus 10 times 2.5, that will be 65. And then 96 plus 24 times 2.5, that will be 156. So that will be the position vector relative to P of the point of intersection. So you can write this down in this way if you want to. You can write this down in this way. 65i plus 156j. Things kilometers, so that will be the position vector relative to the point P. So that will be your question number 10. Okay, so let's move on to question number 11. Here we have to solve this equation for the values of x between 0 and 180. So let's do this one by one. So here we have tan square, here we have tan. So we can factorize tan outside. So you will have tan of x plus 5 equal to 0. So now we can solve one by one. You will have tan x equal to 0, or tan x equal to minus 5. Let's begin with this one. Now when tan is 0 or positive value, it will be in your first quadrant and in your third quadrant. This will be x, the angle, and this will be 180 plus x. So let's find out. X will be tan inverse of 0, which is 0, but also 180 plus 0, that will be also 180. So this is the value of x for this one. Now when tan is negative, it will be in which quadrants? It will be in this quadrant and in this quadrant. So this will be what? And this will be what? So let's first assume we are trying to find the value of theta. So here let me write this first. So if it is in the fourth quadrant, it will be 360 minus the angle. Let's call this angle theta. And this will be 180 minus theta. Okay. Now, theta is not your answer. Theta is tan inverse of the positive value of 5. So why am I doing this? You also can not choose this method. This is just the way I like to use to make it easier for me to find the angles. The idea is to know if it is negative, it will be in my second quadrant and the fourth quadrant. That's the main idea. Now, next step is I know that because it is negative, I will not find x directly. I will first have to find theta. Theta, I assume it is the inverse of the positive value. So theta will be what? Tan inverse 5. That will be, so let's use degrees of course, that will be 78.7 degrees. Now this is not your answer, you have to find x. X will be according to your quadrants. As you can see, this is the second quadrant, this is 180 minus this. That will be 101.3, and we have 360 minus 78.7, that will be 281.3. So finally we can conclude that x has to be 0, 101.3, 180 degrees. So we are not taking this one because it is outside the domain. So this will be the three values for part A. Now for part B, we have to solve this equation again. So as you can see here, what can we do is, if you observe, here we have cos square y. So what is cos square y? It is 1 minus sine square y. So let's replace this back in the equation. You will have 2 times 1 minus sine square y minus sine y minus 1 is equal to 0. Now let's expand and simplify. You will have 2 minus 2 sine square y minus sine y minus 1 is 0. Now, minus 2, that will be the same, so we have 2 minus 1, that should be 1. So we have minus 2 sine square y minus sine y plus 1 equal to 0. Now let's make this become positive. So let's send this to the other side. You will have 2 sine y, this will become plus sine y, and this will become minus 1. So as you can see, this one is a quadratic equation because we have square, then we have linear, then we have constant. So one way we can do this is, let's make it easier. We can say let u is equal to sine y. So you will have 2 u squared plus u minus 1 equal to 0. Now we can factorize. That will be 2u times u. 1 is 1 times 1. To get plus 1, we have, this is 1, right? To get plus 1, we have to have plus 2 and minus 1. So u will be 1 over 2, and u will be minus 1. Now again, we are not trying to find u, we are trying to find y, so we place back the value of sine y. So sine y will be 1 over 2, and sine y will be minus 1. So now we have to solve these equations to find the value of y. Y is between 0 and 360. So let's do that one by one. So for this one, it is positive value. So when sine is positive, it is in your first quadrant and your second quadrant. First will be the angle directly, and this one will be 180 minus y. So y will be what? Sine inverse of half will be 30 degrees, and this will be 150. You can check, obviously. Half should be 30. And then this will be 180 minus 30 will be 150. Now, for this one, so when sine is negative, it has to be in your third quadrant and your fourth quadrant. Again, the same way as we have solved before, because it is negative, I will first try to find the value of theta. Theta will be sine inverse of the positive value. That's my trick, okay? Now, let's first write this down. So if it is in the fourth quadrant, it will be 360 minus theta. So now I'll only write this because it is negative value. So negative, I have to first find theta and then find y. Y will be given by this equation. So here, if it is in the third quadrant, we have to take 180 plus theta. So let's find the value of theta. Theta will be sine inverse of 1. That will be 90. So which means y has to be, according to your quadrants, 180 plus 90, which is 270, but also 360 minus 90 is also 270. So in the end, we have three values. Y will be 30, 150, and 270 as your values for y. That is part B of the question. Now let's move on to part C of the question. So here we have to solve again the equation for the value of z. Z is between 0 and pi radians. So let's do this one by one. So first thing to know is, what is sec? Let's say x. It is 1 over cos x. So let's make cos x become subject. So here we have cos of the angle, which is 2z minus pi by 6 will be equal to 1 over 2. Right? Let me show this to you step by step if in case you're confused. So first thing, let's assume this angle is x. For example, that will be 1 over cos x equal to 2. What is 2? 2 is 2 over 1. So we can simply cross multiply. We send this over here, and we can send this over here. So you will have 1 over 2 equal to cos x over 1. So finally you will have cos x is equal to 1 over 2. Now x is the angle, so cos of the angle is 1 over 2. So that's how I got this one. Okay, now let's solve for this one. If cos is positive, it will be in your first quadrant. So if the value is positive for any trigonometry, cos, sine, and tan, it will be in the first quadrant. So we use this trick to remember, which is A, S, T, C. Now there's many ways to remember this. So one of the ways is all students take chemistry. This is one of the ways that the teachers told us to remember, but of course there's many different variations. If you guys want to choose anything, it is possible. Now this is all, A is all is positive. In this quadrant it is S, sine is positive. In this quadrant tan is positive, and in this quadrant cos is positive. So A, S, T, C will be the values that define which quadrant will be positive. Now as you can see, cos is positive, so first it will be all in A, and then it will be in this one. This will be 360 minus the angle, and then this will be just the angle itself, for example. Okay. Now, I don't want you to be confused. Here it is not negative. I'm not using the method as before. It is just a way of writing for now. Okay. Anyway, so let's move forward with this. So to find the value of the angle, we have to take cos inverse of half. Okay, and that will give you the value of pi by 3. So you can check cos inverse of half is what? Is 60 degrees, which is pi by 3. Now, given that it is in the first quadrant, it will be the angle directly, which is pi by 3, but also in this fourth quadrant, it will have to be 360, which is 2 pi minus pi by 3. So for now we have 2 this minus this is equal to pi by 3, but also, so let's simplify, that will be over 3, that will be 6, 6 minus 1 will be 5, pi over 3. Okay, so right now we have these two values. Now, because this is 2 here, as you can see, we have 2z, what I advise is, let's add 2 pi to each of those values. Okay, let's see what happens. So, pi by 3 plus 2 pi, that should be what? 6 plus 1 is 7, so 7 pi over 3. That should be 11 pi over 3. So right now we have 4 values. Because this is 2, we have to add 2 pi to those existing values. So let's rewrite down our equation. So right now we have 2z minus pi by 6 is equal to pi by 3, 5 pi over 3, 7 pi over 3, and then 11 pi over 3. So right now we have this equation to solve. Now, we can first send this one over here, so you will have 2, z will be, so first value will be 1 over 3 plus 1 over 6, that will be pi over 2, 5 over 3 plus 1 over 6, that will be 1, 5 over 6, pi, 7 over 3 plus 1 over 6, that will be 2.5 pi, and then we have 11 over 3 plus 1 over 6, that will be 3, 5 over 6 pi. Now we want to find the value of z, we have to divide by 2 everywhere, that will be pi by 4. So 1, 5 over 6 divided by 2, that should be 11 over 12 pi. This one will be 2, 1 over 2, which is 2.5, divided by 2, that should be, so that will be 1 over 4, you can expand, that will be 1 times 4 is 4 plus 1 is 5 over 4, so that will be 5 over 4 pi, and finally we have 3, 5 by 6 divided by 2, that will be 1, 11 over 12, so that will be 23 over 12, 23 over 12 pi. This is the value of z. Now, we have to make sure that it is between these domain. So as you can see, this will be outside and this will be outside, so you will end up with two values. There will be pi by 4 and 11 over 12 pi as your values of z. Okay, so that will be the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.